So, good morning, everyone. Great to have you to our webinar on our IDSA Tech Talk webinar on data usage control. My name is Sebastian Steinbuss. I'm CTO of the International Data Spaces Association, and we are glad to present this webinar to you today, which is powered by a couple of the great research projects where IDSA is active in. And today we have our expert Arghavan Hosseinzadeh from Fraunhofer IESE. Presenting some things on data usage control. And most of you know already, it's not only about technology enforcing usage control. First of all, you need to specify a contract. So you need to understand what you can put inside, how a usage policy looks like, how to use ODRL for that, before you can then eventually enforce it in technology. So I'm not the expert, Arghavan is the expert. Arghavan, I hand over to you. Let me give the screen share to you, and thanks for presenting today. We can see a slide right now.
Okay, great. So, hi everyone, my name is Arghavan Hosseinzadeh. As Sebastian said, I am from Fraunhofer IESE, Kaiserslautern, Germany, and it's some years that we are active in the usage control component activities of IDS, and today I will talk about data usage control. So let's start with what I will present today. It will be about a short introduction about the definitions of access control and usage control. Then I will talk about the policy specification process, what an IDS contract is, what are the policy templates, policy classes, which policy languages we use, what is a policy negotiation, what is policy transformation, and then I will talk about policy enforcement and usage control technologies. So let's start with what is access control. It restricts the access to the resources. So always when we are talking about access control, it is about authorization. The authorization is the process of granting permission to the resources. There are different models defined for access control, for example, role-based access control. For role-based access control, of course, we check whether a role of a user is what is requested. For example, only administrator can access this data, only developers can access the data, and etc. The other model that is very much well known and very much used is the attribute-based access control. It is about defining attributes and values and then check whether these attributes and values are as demand and then provide access to the resource. The attribute-based access control is also known as policy-based access control. So it grants the rights to the user based on defined policies. Policies combine attributes together. The attribute may be such subject attributes, so it can be about the users themselves. It can be resource attributes, so the attributes that are referring to the data artifact. It can be environment attributes, and etc. Mostly the models support the Boolean logic in a form of if-then else statements. So for example, you can define a policy that if a requester is a member of IDSA, if the title of the document is, for example, data usage control in IDS, if the location is Germany, then grant access. So here on this right side, you can see that the attribute and values will be checked. And then there will be the question whether the access shall be granted or not, and the answer is either yes or no. So talking about access control, we can think of XACML architecture. XACML stands for Extensible Access Control Markup Language Standard, but it's not only about the language itself. It provides a processing model about how to evaluate this policy, and that is what is interesting for us. So this architecture, how to actually evaluate a policy and enforce it. So look at this right side. We have a user and we have a document. The user wants to access that document. Then there will be a component, policy enforcement point, shortly call it PEP, that takes care of this provision. But how PEP knows that when intercepts its data flow should actually provide permission to this user to access the data? PEP will ask the policy decision point, so PDP. PDP acts as a brain of this architecture, but has to make this decision based on the policies and the information, so the values of those attributes. Has to make this decision based on the policies. On the other hand, we have this policy administration point that you can define your policies. The policies are stored in a repository, which policy retrieval point takes care of. And then PDP that wants to make the decision gets the policy from the database, gets the attribute values from the policy information points, and makes a decision. So from the example that I just mentioned, PDP asks the information point, is the user a member of IDSA? Is the document called this? Is the location is Germany? And when all are marked as yes, then the decision point can inform the PEP that you can let the data flow, you can let the user to access the data. But what is usage control? Usage control is an extension for the traditional access control. It enforces modifications and filterings, it executes obligations, so enforces usage restrictions after the access has been granted. So look at these examples. The question is not only whether allow access, whether the user can use the data or not. So it's not only a yes or no question. The answers are more complex and covers more cases. For example, it can be that yes, but only for 3 days. Yes, but inform the data owner. Yes, but only in an anonymized form. Or no, the incident should be reported. So, and so on and so on. These obligations, this filtering, this taking care of these restrictions after the access is granted, that's what is usage control. So usage control is not only about provisions, but also about obligations. So talking about XHTML architecture, we can add a component, we call it policy execution point, which actually takes care of these obligations. So for example, can notify a data provider. So much talking about usage control. Now I would like to talk about policy specification, but first thing that we need to know when talking about policy specification is what is an IDS contract. The information model of IDS defines an IDS contract as follows. It says that an IDS contract is an abstract set of rules governing the usage of a resource. A contract, you can call it a policy, is divided implicitly into 2 main sections. So it's about the metadata of the contract. For example, the data contract was issued. And then it's about the usage control rules, the obligations, the prohibitions, the permissions, statements that are about usage control. And that is the part of the contract that is especially interesting for us. When we want to express a policy, when we want to express a contract, it's always a question how it should be expressed. We of course can express it in a text form, in natural language, in English, in German. It's human readable, but it can be fuzzy. We can also express a policy in a machine-readable format, in, for example, XML format or JSON format, and in that way, a machine can actually parse it. And also, we can specify a policy in a machine interpretable way. That's how we call it when a usage control technology, for example, can not just read it but also can understand it, so can enforce it, can make a decision based on that. So when we wanted to actually go through which kind of policies can be defined, we had this challenge that how we should express it, how the policy that I define, whether in natural language or whatever, can be understood the same way that you would specify a policy, and how do we know that which policies we can enforce or we cannot enforce it yet. So we decided to have templates. That's what we called policy classes. But policy classes are simply atomic policy templates that refer to a specific restriction on the data usage. It can be about some conditions, or it can be about some obligations before or after the data usage. I will go through these policy classes, and then we see better how these templates are going to help us. For example, a very basic template is about allow or inhibit a consumer to use the data. So in general, it lets a data consumer with all their connectors use the data however they want. We can also restrict the data usage to specific connectors. We can restrict the data usage to a group of data apps that are available. We can restrict the usage to a group of users, to specific locations. For example, we can say that doesn't matter where the participant is actually registered, but the data must remain in Germany and has to be used in Germany. Restrict the data usage for specific purposes. For example, data only can be used for research purposes. We can restrict the data usage to specific events. For example, data can be used during this or that exhibition only. We can restrict the data usage to security level of connectors. The information model of IDS defines different security levels for the connectors. There can be a policy that says only connectors that fulfill the security level Trust Plus can use the data. We can restrict the data usage to specific time interval and duration. Of course, it can only use my data at this year or until end of 2024. We can restrict the data usage to the time of to how many times the data is being accessed and used. You can demand that the data shall be deleted after it is used. You can demand that the data shall be filtered or however modified in transit or in rest, so when the data is stored in a repository. You can demand that the usage information should be logged. You can demand that the usage information should be given to a party. So a data provider can say that when the data is used, I want to be informed. You can demand that data can be only distributed when a policy is attached to it. Or restrict the usage of the data to specific artifact state. For example, data only can be used or distributed when it is encrypted. You can specify policies for data rent or data sale, and also you can restrict the usage to specific state, so not just the artifact state, but generally you can say that when it's emergency data can be used. These policy classes, so these templates, were introduced in the latest version of usage control document in IDS. We have more policy classes to add, that is the main point of having the policy classes, so having the template. When the project grows, when there are more use cases, when there are more stakeholders, there are always more templates to be introduced, but the point is that having these templates are just to help the users to define their policies. Let me mention shortly these new policy classes too. So you can restrict the usage of the data to the location of the participant. So where the participant is registered actually matters. Restrict the data usage to obtain users' consent. You can imagine, for example, in health domain, that's a very common case that user consent is needed when the data is going to be used. Restrict the data usage to the data classification. You can classify the data in however category that you want, and for example, you can say that only public data can be used, only data that are labeled as research can be used, or something like that. Anonymize data before data is used. For example, if specifically you mention that data shall be used only when differential privacy is enforced, only when multi-party computation is enforced and used. So these are the other policy classes. But now that we know about these templates, we know that we can pick them, we can instantiate them, we can combine them, and then we have our policy. So that's how we define a usage control policy. A usage control policy is an identified policy that is a combination of one or more instances of the policy classes. In this box, I have an example for a usage policy that is specified in natural language. The policy is identified, there is a UID for it, it's issued at this time by data provider X, and then there comes the usage statement. The data consumer Y shall use my data asset. This is also clear which data asset we are talking about, not later than end of May 2024, and only when the usage location is Germany. In addition, the data usage information shall be logged, and all the copies of the data shall be deleted afterwards, and I want to be informed after this obligation is fulfilled. So this is an example for a policy, but you can see all these different policy classes that are actually instantiated and now combined together made this policy. We just expressed that policy in natural language, but we wanted to have a system, a framework that policies can be shared, they are machine readable, they are interpretable, the enforcement can be automated. So we needed to decide a policy language that can be our basis for expressing policies. The ODRL policy language was chosen. ODRL stands for Open Digital Rights Language, and there was two main reasons why this language was chosen. The first reason was that it's simple. That's actually very important. So look at this, this policy on the left side. You can follow the attributes. It's in the JSON format. You see that there is a context, there is a type that refers that this contract, this policy is an offer policy. There is an identifier for the policy. There is a profile that says all this terminology that are in the ODRL profile can be used in this contract. And then we have the first permission block. In this permission block, the target is referring to the resource, and then we have the assigner, which normally is the data provider. And then we have the action, which is in this case distribute, and then we have the constraint. So this policy is simply saying that the organization 616 is allowing permission to use this document to distribute it in this time interval. It can be a little bit more difficult, but still simple. On the right side, you can see that you can define duties. Duties are those obligations we were talking about. You can specify that there should be a payment done before the consumer can actually play that, in this case, MP3 file. So you can also define your obligations. You can say that should happen before that action, play or use or distribute, or afterwards. The second reason that ODRL language was chosen as the main language of IDSA was that it's extensible. As ODRL also mentions in their info model, an ODRL profile explicitly serves community needs. The point is that if you check the vocabulary of the ODRL information model, you see a fixed set of actions, attributes, left operands, and so on that you can use and express your policy. But in your community, in our case, in IDS, we have terms that we need to use them to express our need. And ODRL allows us to define those terms, create a profile, and just use it. For example, first term that exists in IDS and it doesn't exist in ODRL, and actually is very important for us, is about connector. And if I want to specify a policy that restricts the usage of my data to specific connectors, then I wouldn't have any left operand in ODRL terminology that could help me. So that's why IDSC connector, for example, was defined. And defining it, this you can find it in the information model of IDS. It is defined that it accepts IDS connector URI. And so in the policy, you can say that my data that is an inventory data set that can be used from 1st of June until 1st of October, and only connector C1 and connector C2 can use my data. But the question that arises is that, do people need to know how this ODRL language works to specify a policy? Actually, these policy editors can be used in a way that anybody can just fill the templates and create the policy that he or she wants. So in this example, you can set that the policy that you want to define in an offer policy. You can refer to the URI of your data. You can set a restrictions. So at this policy class of the time interval there instantiated, say from 1st of June to 1st of October, at the other policy class of connector, and say that only these connectors can use the data, and press on the button generate policy, and then that policy will be generated for you. So when we talk about the policy specification process, actually this policy editor is the beginning of the process. Always the data provider is thinking that, okay, I want to offer my data and I want to specify a policy for it, so I can use the policy editor. As a result, a contract offer is created. On the other side, there is a data consumer that can use a policy editor and create a request. But this contract request and contract offer need to go into a negotiation process so that an agreement is created. So if I offer something and somebody that wants to use my data creates a request that is exactly identical to my offer, then we have an agreement. So I offer this data for this price and this time to this time, only for research use, etc. And the consumer says, yeah, everything that you are demanding is fine for me, and then we have an agreement. But negotiation can be a bit more complex. It can be that a data consumer starts the negotiation process, but demands for slight changes on the contract offer. So says that I actually want to use the data for longer time. I want to use it for other purposes as well. So these policy classes that I mentioned before are potentially places where the data provider and data consumers can negotiate over it. In this slide, I have a sequence diagram that shows how this negotiation process, how this messaging actually happens between the data provider and data consumer. The point is that in the backend, there can be a user, an operator that decides over which contract they want to create or not. It can be also that it is automated. So if you can implement your demands in the backend, the process can happen completely automated. An authorized connection will be established between the provider and between the consumer. A consumer initiates the negotiation, sends a request message, and the provider provides the consumer with an offer. And then the consumer decides whether that offer is accepted and creates an identical request for it. And if it is identical, as I explained just before, the agreement will be created. If not, this loop will continue. So I will create a new request. You will check if that request is fine. You will create a new contract offer. So we will bargain over our demands, and at the end, either a new offer is created and the negotiation continues, or the contract is agreed. So we are at an agreement point, or the contract is rejected. When the agreement is created, the consumer still has to acknowledge it. Here at this point, we reach that point that we have the agreement. That is the policy that has to be enforced, that it has to be followed by all the parties, and the data can be transferred. But still there is another point that is optional. If the parties decide to use a usage control technology to enforce these policies into their systems, they have to consider the policy language that their usage control technology understands. So each usage control technology can have its own implementation level policy. We have examples of implementation level policies. For example, my data language, Lucon has its own language, Reiko is another language. So all these languages, if you want to use a technology, it has to be considered, because this agreement, which is in ODRL, has to be then transformed to the technology-dependent language, and then it can be enforced. So now that I talked about the technology-dependent languages, then I would like to shortly introduce some technologies. One is my data control technologies. It is based on INDUCE framework, and it is developed at Fraunhofer IESE. It implements data sovereignty by monitoring and intercepting security, relevant data flows. It has its own policy languages and XML based language, and also it provides its own policy editor that I showed a picture of it here. The My Data control technology is based on XACML architecture as well. So it has PEP that takes care of the modifications. For example, remove all customer addresses before releasing data to external parties. That happens in the PEP. There is a policy execution point that takes care of the obligations. There is a policy information point that resolves the attribute values. Also, there is a PDP, policy decision points, that takes care of evaluating the policies. There is a POP, policy administration point, that takes care of specifying policy, provide a user interface, administrate the policy itself. And then when the policy is created, will be stored and managed by retrieval point and management point. The other technology that I would like to mention is LUCON. LUCON stands for Logic-Based Usage Control. It's developed by Fraunhofer, ISAC, and is part of the trusted connector. It controls the data flows between the connectors by message labeling. Of course, that also has its own policy language. So in this example, you can see that there is a policy rule. It is identified as anonymized. There is a description for it. Do not leak personal or internal data. And it is specified in a way that, say, when it comes to a public endpoint and receives a data that is labeled as personal or as internal, then it has to be dropped. So you can get more information about it online. The next technology that I would like to talk about shortly is OPA. OPA stands for Open Source Policy Engine. It is a general purpose policy engine. It's open source, and it also provides its own policy language that's called RAGO. It accepts arbitrary structured data as input. Here also I brought an example of a policy that is specified in RAGO. For example, you can say allow usage of data or access to the data if user is called Alice. Allow if user is Bob and the method is get. Allow if method is get and if the user has the role dev, like it's a developer, for example, and so on. So we saw how different policy, how different technologies have their own policy languages, and how then a policy transformation would be needed when we want to use those technologies. But I also always mentioned that there are policies that refer to a data. But also it is possible that we describe the data, and in the data description, we refer to a policy. So ODRL defines a property has policy. Also, it is being used by data catalog vocabulary, so by DCAT. So it is bi-directional. So data can be referred from a policy by the target attribute, and a policy can be referred by data which has policy attribute. Now I would like to talk a little bit about the enforcement. So we have the policy, it is specified, it is understandable. Let's say for now that it is just in the natural language specified, but what should I do? How should I actually enforce it? In this example, we have allow the data consumer A to use the data, so display and print it, and restrict it to a specific data apps. What we understand here is that there is no restriction of the connectors. So if a data consumer has more than one connector, all those connectors can use the data. What else we understand is that we have the enforcement points where the data is being used, where the data is being displayed, or where the data is being printed. We also have a restriction. We have the restriction that specific data app can use the data. So I need a policy enforcement point, policy information point that I can ask whether the data app is what is in the policy and allow the data app to use my data or not. So just looking at this policy, I know which PEPs I need, and which PIP I need. Now look at this picture. We have a connector, we have a core container, we have a usage control container, we have a data app container. This usage control container would take care of the policy evaluation, so evaluating the policies. And then we have the enforcement point that takes care whether the data can be used by this connector or other connectors of the same consumer. And then we have a PIP that can provide information about that data app so that the policy can be evaluated. Then we have two other enforcement points for display and for print. And then if it is allowed, so that data flow is released so the data can be displayed and printed. That can get more complex. It can be that a data consumer does not allow the data consumer A to distribute the data, or it can be that a data provider allows the data consumer to distribute, but says that only if the policy is attached. So clearly here also we need an enforcement point. The point where the policy has to be enforced is where the data is being distributed, so distributed to a different consumer. That's why we have a distribute PIP. That's where this decision will be enforced. And if not, that will be blocked. And if yes, if it is okay, it will be released, but there will be a PXP that takes care of that obligation of attaching policy to it. It can get even more complex. It can be that the data provider allows a consumer to process the data, to store it in the connector, but demands to delete the data after. So again, we see that the point that the enforcement has to make a role is where the data is being processed and where the data is being stored. So therefore, we have a process enforcement point. We have a store enforcement point. But since the data is demanded to be deleted, then we need an execution point, a PXP, that takes care of this delete action. We can think of the case that a data consumer A wants to consume the data on a cloud, whether it is controlled by IDS or not, and demand the data that has to be deleted, all the copies has to be deleted from there too. So in those cases also we have this store and read enforcement point, and also we have to have delete a PXP that takes care of deleting these copies from those repositories. And for that, IDS introduces a system adapter app that can support in that way, or it can be not using the system adapter app. But as you see, when the policy gets more and more complex, there can be different enforcement points, there can be information points that are needed so that you can resolve your attribute values. There can be different points that execution points are needed. But at the end, it depends on the use case. It depends on how and where you want to use the data, and so you can actually define these enforcement points. Last but not least, what I would like to mention in my presentation is that we consider usage control as a contract that shall be fulfilled by a party. The IDS participants can invest, use technologies and investment efforts to actually technically enforce these policy rules, but at the end there will be a part left that cannot be technically enforced and has to be taken care of in an organizational way. Usage control is supposed to support the participants to protect their data, and the usage control technologies are supposed to support the participant to technically enforce them. But at the end, we should see it as a bunch of rules that has to be fulfilled, and it will be the responsibility of parties to make right decisions how to fulfill these contracts. Actually, yeah, I am finished with my presentation. I'll be happy to hear if there is any question.
Arghavan, thank you so much for the presentation. So, there's my camera. Thank you so much. That was interesting again. So there is one thing that I would like to underline and to mention, because, well, Arghavan, the both of us have conducted such webinars before, and I spotted something new, and this is that you also mentioned Rego and the Open Policy Agent. Hey, that's cool to also outline a little bit the connection between those two aspects, because honestly, I discussed this a lot during the last years. I do not see at the moment any questions in the chat, so either your presentation was very precise and clear, or people, well, did not write yet. So I give you the opportunity to write questions in the chat, because I would have a question for you, Arghavan. This week I've been at the MyData, so the other MyData, the MyData Global Conference, where they talk a lot about human centricity and human-centric services. So what you showed is about ODRL, and that you can create policies based on ODRL and they are transformed into technology. But you also showed this editor. So as a human being, and not being a programmer or a software developer, that means that I can also create my own policies and describe what I want to have done with my data on a more human-friendly way. Did I got this right?
Yeah, exactly. That's the point of having a policy editor, so that it can, people with different backgrounds and expertise, they can use the template, fill the template, and create their policies and not be worried about not knowing how the language actually works. So yeah, that's exactly the point.
Yeah, that's a great achievement, really, to really get track and usage of such policies. But another question here. You also showed this diagram, how to negotiate policies. And what you described is basically it starts with my data offering and also with my policy that I would attach to this. And then we can negotiate. Could also a consumer request data from me and say, well, that's my policy, that's what I offer to you as a contract, and then you can start the negotiation from there. Is that also an option?
Data consumer always has to start a negotiation, so that shows the interest that, yeah, I want to use your data. Either a data provider publicly provides the offer, and the consumer can investigate it and say that, yeah, that's the offer I want. So I will start a negotiation, and then I will hopefully get an agreement. Or the offer is not available publicly, but I still know that I would like to use that data, then still I have to start a negotiation as a consumer and say that, can you provide me the offer so that we can negotiate and talk about it and make then an agreement. So always a data consumer shall show the interest by starting the negotiation process, and hopefully that will be short and everybody agrees fast, but at the end that should end to an agreement signed by both parties so that it can be enforced.
Mm-hmm. Yeah, great. So negotiation is always good until reality steps in, and but that's another story that we not two technical guys have to discuss. But coming back to the technical thing, I mentioned the thing with OPA and Rego before, and so I'm also following IDSA since a while, and we discussed a lot about my data, about Luca, and also about other technologies. And then out of a sudden, at least for me, OPA and Rego stepped in. So I assume the next technology will just show up in the next years, sooner or later. But how you described it, so the approach that you present is open to use any other technology. So guys, feel free to invent your new cool technology for usage policy enforcement in your own language. That would also work if I got you right.
Yeah, I always see that people ask this question because they feel they are obliged to follow some technologies. But the idea of IDS, as we all know, is to provide a framework for data sharing, of course, in a secure manner. But that framework has defined protocols. Participants can use a technology to enforce their policies or not, or just follow the protocols to implement it however they want. But the point is that these technologies will help them a lot. And as you said, there may be more amazing technologies coming soon and provided. So IDS will not point to specific technologies so that the participants have to follow that, but it is supported, or it's available, so they can use that. Yeah.
Yeah, I would like to underline that definitely, because it is important. I always, or not always, but sometimes get the question, so I have to implement XACML when using IDSA. Well, maybe not. So this is an outline, there's an option explaining so how it can be used. And I like also your presentation and our approach here to say, well, of course, this is the idea, and this is how we envision it in IDSA, and we show how you can implement it. And there are solutions available that you can use already. But if you have a cool idea or some strange requirements, well, then let's get it from scratch and start implementing, building your own thing. But on the other hand side, you're interoperable. This is what I really like with the ODRL contracts and policies, that they're interoperable. The both of us understand it, and they're independent from the technology that I use inside my connector.
Yeah, exactly. That's why we call it the machine readable, but not necessarily machine interpretable. So these implementation level policies that the technologies rely on them are different level, but ODRL is a language that is simple. Human can understand it. It can be parsed by the machine, so it can be just the basis for the specification of the policy.
Yeah. Yeah, and also for security considerations, maybe you don't want to run any kind of code or policy that is executable inside your own connector that you didn't implement on your own. But that's a different story for another webinar, I think. Folks, last chance for you to speak up or type a question in the chat. Arghavan, you did a great job. Thank you so much. We really appreciate your expertise and the time that you spent explaining this to us. I know that a lot of people are following this and are implementing and working exactly on such technologies, and I like that it really got moving. I remember times when IDS and data spaces were a new topic. Now we are in the movement. So folks, if you have any questions and watching this on YouTube, just reach out to Arghavan, reach out to the IDSA head office. We are here to help and to answer your questions and get those cool technologies and concepts really going. Arghavan, thank you so much again. Have a great day.
You too.
Take care,
Bye.
folks. Bye.